In this last example, we want to solve an equation for x, and we want to use double angles to get us there. And now let's first look at this and think, well, why do we need to apply a double angle identity at all? If I wanted to solve this, I've got sine of 2x plus sine of x equals 0. Well, now I know I could definitely graph this, right? I could plug it into my graphing calculator, look for where it crosses the x-axis, and I'd be just fine. But let's see if we can apply an algebraic approach to this. As it stands, I can't combine these. They're not like terms. Since I'm taking the sine of 2x, I can't combine it with the sine of x. That's just like if I had the sine of square plus the sine of circle. Those aren't the same things. I can't stick them together anyway. I can't pull this 2 out of this double angle. So we need another way to make this kind of look like something I can manipulate. So let's see if we can use the double angle identity to make a substitution. So if I substitute in using the double angle identity for sine, this will be a 2 cosine of x. That kind of looks like a plus sign. Let me try that again. 2 cosine of x sine of x plus sine of x equals 0. All right, well, did that really help me? Now I've got a cosine in here as well. But I can factor something out. So now this looks like something I can work with. If I factor out a sine of x, what I have left is 2 cosine of x plus 1 equals 0. Now I have two independent equations that I can split and solve independently. So here I'm looking when sine of x equals 0, and here I'm looking for where 2 cosine of x plus 1 equals 0, or where the cosine of x equals negative 1/2. Now I've got some nice unit circle values. So my boundaries are between 0 and 2 pi. So the sine of x is going to equal 0 in two places. It's going to equal 0 at 0 and at 2, or actually 3 places in these boundaries. 0 and pi and 2 pi. And for when cosine of x equals negative 1/2, that's going to happen in the second quadrant and the third quadrant. So that's going to be 2 pi over 3 and a 4 pi over 3. So if I put it all together, x can equal 0, 2 pi over 3, pi, 4 pi over 3, and 2 pi. So I had to use a little bit of a double angle identity to make this like something I can work with. But once I was able to do that, I could factor stuff out and solve this like a normal trig equation. Why don't you give this problem a shot? Again, we want to use a trig identity. This one's a little bit trickier since I started you off with cosine of a double angle. And so you've got some options here. So see if you can find which formula you want to use to make your life the easiest. And worst case scenario, if your first attempt doesn't work, try another formula and see if that one works. So pause the video and give this one a shot. All right, it turns out that the answer comes out to be something like this. Probably the ideal identity to use would be the one that's also involving cosine. So that's going to be 2 cosine squared of x minus 1, and then you have minus cosine of x equals 0. And from here, you can factor this. You can rearrange it to factor this to something that will work out, and that's where you're coming up with these solutions.